Clap. Hey everyone, let's understand this problem 1404. It's a number of steps to reduce a number in a binary representation to 1. So, have you ever seen a binary problem that looks easy, but the carry logic completely messes with your brain? So today we are breaking down this problem into very simple possible way. So by end of this video, you will understand how the intuition works and how you can master the greedy carry trick, and we'll try to implement in Java, and it will take time complexity of n times. So the thing is, we have given this problem, uh, and these questions give you that a binary string. As you can see, string s equal to 11 11 0 1. We can say that 1101, not 11. So you must reduce to it to 1, and rules are very simple. If the number is even, we have to divide by 2. If the number is odd, we have to add 1. So we have to count how many steps it takes. And now the main key is, in binary, if ends with 0, it's even. If it ends with 1, it's odd. The very first thing is, we have given this question, and the question says that you have given a binary string, as you can see here, right? Give me 1 second, guys. So this is the binary string we have given. Okay, so this binary string is very important to understand why we have given this one. Okay, let's try to understand from here. The very first, we have to convert this given binary string, right? What we have given, right? So we'll say there is binary string. Okay, and this binary string should be given, like, let's suppose we have 1101, right? So this should be, means our task should be to convert it into what? 1, using two rules, or using these rules. The very first rule is, if number is even, if number is even, right? If number is even, it means it ends with 0. If it ends with 0, it means we have to divide by. If it ends with, then we have to divide by 2. Understand? This is the concept. If the number is even, ends with 0, then divide by 2. Then another concept where we have is, if number is odd. The number is odd if and only if ends with 1. Okay, then we have to add. We will not divide, we will add 1. Okay, so these two rules we have given. And what we have to do, we have to count how many steps it takes. Okay, this is what we have to find. Understand, guys? The very first thing I told you to understand, that we have given a binary string. If we have given this binary string, we have to convert it to 1 using these two rules. If the number is even, if it ends with 0, we have to divide by 2. If it is even, divide by 2, because it ends with 0. If the number is odd, it means it ends with 1, and in this case we have to add 1 with not to divide. We have to count how many steps it takes. Now think that we have given, okay, we have given, let's suppose the input, what was the input was given? It was given 1 and 1101. Okay, so the input we have given was, from the example, is in the string we have given s equal to 1101. Now, in the very simple thing, we should understand that we have to convert to decimal, right? Means if we want to convert to decimal, how will convert this? Let's say 1101 will be converted into, so we have the formula 8421, where if you say 1101, it means 8 4 is 12 and this 1 is 13, so it will convert it into 13, correct? So if we'll convert this into decimal, it means it is 13. Now the simple rule is to understand we have to convert into the steps, right? So let's go to the steps. The very first step is to, we have binary. What is the binary we have given? Let's say we have given the binary, and we will convert into decimal. So we have 1101, we have converted into 13 as a decimal. So what operation is required? So we'll say the operation required is odd, right? Because it ends with 1. Then it means we have to do plus 1. Once we do plus 1, the result should be what? It should be 1110, right? After adding 1, after adding plus 1, right, it will become like this. Similarly, now we'll use this binary 1 sorry, this 1 1 0, right? So this is nothing but 14. We know that because single 1 bit has changed. Now it is even because number of 1, right? If we'll say, sorry, decimal is 14, that 14 is divided by 2 easily, and so it become odd, right? So it means we have to divide by 2, we know that, and so we can say 14 we have to write into 7, so 7 is 111, right? 8421 based on that. Now we have the binary is 111, and this is nothing but 7 as a decimal. 7 is an odd number, and for the odd you just need to do plus 1 bit, right? 1 bit we will add, so it will come 100, like this, right? Because this is 8, 1 bit. Then the binary is this is 8, it is even number, so we will divide by 2. If we will divide by 2, so it will become 4, and to make the 4, 100 will become. Now 100 is there, it is nothing but 4, it is again even, divide by 2, it will become 2, means 10. Now take 10 and you will say this is 2, it's still even number, divide by 2, so it become 1. So at the last you will get 1. So if we will count how many steps we have took, so we'll say 1 2 3 4 5 6, means total 6 we can say, 1 2 3 4 5 and 6, and that is why our answer should be 6 steps, right? Let's check. So if you see, the answer is 6 here, correct? The answer is 6. Okay guys, the answer is 6 we have, and this is correct. So like this, we should say that this is the thing we have to do, right? It means if the binary we have given, we will convert into decimal, right? If this binary we have given, right, we have to convert into decimal, then we have to perform some operation. We'll check this decimal is odd, we'll do +1. If decimal is even, we'll do divide by 2, and like that we have to keep continuing until we reach to the 1 bit. Okay, this is what we have to do. Binary, this is called binary transformation, right? Because we are transforming the here, and again we are coming here, means we are transforming like this, right? So this key insights is very important to understand. So instead of converting to decimal, right, here, like we are converting to decimal, which is very slow for the large inputs, right, we can operate directly on the binary string. Okay, what I'm saying, we should understand the very key important is, what is the key important before implementing this question? Important. What is the key important? So we should not we how we can say, we can say if we convert, right, converting to decimal, converting to decimal, we can say, yeah, if we'll do converting to decimal, it will become slow, right, when for larger input. Okay, so it is not required. Then what we will do, guys, it means we should operate, or we operate directly on the binary string. We should directly operate on the binary string. Now the thing is, how will you do that? So let's try to understand. Just think that we process the bits. Let's suppose we have 1 1 0 1. Okay, string like this we have. So let's suppose from left to right, if we will process the rightmost bit and the leftmost bit, right, from rightmost bit to leftmost bit, because the rightmost bits will tell if it is 0, it is even, if it is 1, it is odd. This is the simplest trick that we should use, right? Because if we'll read 1, it is odd, it is 0, it is even. So let's try to understand here. For this case, let's suppose what I'm trying to say here is, when you say the index is 0 1 2 and 3, so when the value reaches to the pointers, right, so let's suppose we'll start from the rightmost pointer, sorry guys, from left to right, not right to left. So from here, this is your right and this is your left, so we should move like this. Okay, so in this case, we'll start from the pointer rightmost, so it is this one. Okay, so we'll start the pointer from here and we'll keep moving ahead in this window, right? So very first, let's suppose we have case 1, means we got, let's suppose bit is 0 initially. So when we got the bit is 0, we should divide it by 2 and we'll move to the left, correct? If let's suppose if the very first bit is nothing but 0, it means we'll check, okay, it means it's a even number. So divide it by 2 and move the pointer to here, from here to here. Okay, when we reach the next like that, we have to think, right? Because the bit is 0. If bit is 0, it means we have to divide by 2 and we'll move to left. Similarly, in the case 2, let's suppose if the bit is 1, you know what we need to do. So when bit is 1, we have to add 1 because it causes the carry, right? It causes carry. Then consecutively it will turns it into consecutive ones, right? So it become 0. So the first 0 becomes 1. So like that we have to keep moving. Let me tell you how in the detail. So let's suppose start from very first is we have given 1101. So the very first bit is nothing but is 1, which is odd, right? And we know that if the bit is 1, right, it is odd, right? But we should also check the consecutive one. So don't think right now. This is one bit. It means we have to add plus 1, right? So how will you add? So this will become 1101, and if we'll add one more bit, right, it will become 1110. Means we have moved. Now let's move this pointer. So once you will move the pointer, so this is the first steps we can say where we have converted this one, right? In step 2, what we need to do is we have 1110 right now. So we have, because now we have to move the left, right? So it is coming even. So if the even comes, we'll move left, right? So just increase one more bit here, correct? From here to here, this side. Now from pointer here, it will move to here. Understand? So no more pointer left there. Because why we have done? Because it was 0, and when 0 is here means it's even. So we have move left. Okay, remember here. It was odd, so we just added 1, and we have added 1, we got this one. Then we saw that this is 0, it's even, so we have moved left. Understanding? In the step 3, we need to say only triple one will left, and the pointer is at this position because we have ignored the 0. Now 1 is there, it means it's odd. You know that what you need to do? You need to just do plus 1. Once you do the plus 1 with the, this is nothing but the 7, right? 1 bit. So once you add this 1 bit, it will become nothing but is 1000. So once you added 1 bit, right, it will convert it to from 7 to 8, means 1 bit. Again you have to reset, right? The reset point will comes, and it will keep going like this. You have to reset the pointer again to this position, and you have to keep checking the value. At the last, you will get only 1 bit by processing this way. I hope you are understanding, guys, right? The very first, we have seen that we got the binary string. We'll start from the very first what you call this index, and we'll go in the from rightmost to the leftmost. The very first we got is odd, and if we got the odd, we'll do plus 1 and we'll convert into this. Similarly, if it is even, we'll move left. We're moving left, and then we are getting the 7 because 1 bit is left. We ignore this bit. If it is 1, we'll say okay, do plus 1. So we got this, and so on. We will keep moving ahead, right? The very simple thing is we go from the left to sorry, right to left, right? And if there is one, if the bit plus carry is there, let me tell you what is the thing we have to do. Very first, we should take some steps, right? We have to find the steps. We'll say in steps, and it's nothing but start from the 0, and at the last we'll return it, right? Steps. This is what we have to do, correct? Before jumping to anywhere else, let's think that if some carry is coming, so we'll say int carry, there will be carry. If carry is there, we'll say is 0. If any carry comes, we just need to add the carry here. Is carry here. Okay, how the carry will works? We already knows. We'll understand again. Don't worry. So we know that we have to start from the rightmost bit, right? We have to exclude the very first bit, right? So let's say how. We'll start from the for loop that is called int I equal to 0. Not 0, it should actually start from the last index. So s dot length we can do, we can find its length. If we'll do -1, that this is called rightmost bit. Then we have to go till I is greater than 0, means we have to ignore the first bit because we have to return that. We have to leave that, and then I minus minus. Okay, what we are doing here, we are starting from the rightmost bit and we will go till the first bit. We will not go to the first bit, we'll exclude that first bit. Okay, then let's suppose if I want to find the bit, so what is the bit we have here? So we'll say okay, s dot char add will find, and there will be some element will be there. If we'll do minus a single bit, let's suppose 0, then we will say okay, if the bit is and plus the carry, if we have something carries there, if it is equal to 1, it means this is a odd. So we'll say this is odd case, else even case. Now when we got the odd, means we have to update our steps. How? We'll do just do plus 2, and we'll say okay, carry is what? Carry is 1. Why? I will tell you, I will explain here, don't worry. Then if we have a steps plus 1, if we'll do, so you can do like this also, 1. So each time we are if it is even, we are increasing the steps by 1, and if it is odd, we just do plus equal to 2, and we are taking one carry here, and if any carry remains, we'll just update there. Okay, let's see. We submit. So it's working fine, right? Let's understand here. So it is very important to understand what we are doing here. The very first, we know that we have to do that rightmost bit we have, right? So the rightmost bits to, we have to go to the leftmost bit, right? This is what we know. Why? Because the rightmost bit will tell you if it is 0, it is even. If it is 1, it is odd, right? We have talked about this one. So the concept is, let's suppose that we have given 1, 1, 0, 1. So if we'll talk about the index, this is 0, 1, 2, and 3. If our pointer is at this position, at the starting position, because we have to go like this from rightmost to the leftmost. So we have understood that there is a case 1 we have. So the case 1 is what? If the bit is 0. If the bit is 0, just divide by 2. And we have to move pointer left, right? This is what we have understand. Then another thing we have is case 2. The case 2, when the bit is 1, it means we have to add 1. But if we'll add 1 and if we'll cause the carry, it means we have to turn consecutive 1s, because it will become 1s to 0s. So the very first 0 becomes 1. This is the concept we should understand, right? So we have seen moving this already, this 110, and we have reached till the one bit is left, and we received by the 6 total steps, right? We have already seen. So the observation we have to see that every 0 becomes 1 step. Every, what is the every, let's suppose if 0 is there, means this gives you the 1 steps, because it is called division, right? If every one we have given, so it gives you 2 steps. One is to odd and another is to divide. This is the main concept here. But if we have consecutive oneness, that causes a carry chain, right? So third it comes is, but if we have consecutive oneness, it will causes a carry chain. Okay guys, that is why if you see, if it is odd, means if the if 0 is there, it will take one step, I mean that is called division, right? So we are adding just 1. If we are taking 1, if it is equal to 1, as you can see in this, right, we are just adding 2 steps, we are not taking 1 step. But if we have consecutive 1, that will cause the carry, and so we have to carry the chain only. Okay, so this is a simple steps to understand, right? Any, if you are understanding the intuition, means every 0 bits is there, every bit is there, it gives 1 step, that is division. If we have 1, it means it gives you 2 steps, add and divide. And if any consecutive ones comes, it give you the carry chain. And so we have to, very first we have to find the bits, and then you will check if it is equal to 1, means we have to add 2 steps, otherwise 1 step, right? So instead of modifying the string, take a carry and try to do that. This is what we have in this video guys. In case you are seeking with DSA and Java, Spring Boot, or any other language to do the preparation, you can join our online classes, and for that you can ping me on the WhatsApp and you can have learning. Okay, better plan, better structure, that we can discuss later. So that's all I have in this video, guys. Let's continue to understand, and let's meet in the next
Thank you
video.
guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.